Hello, Aja.
Hey, Jason.
Aja, I was thinking, which is the terrifying thing in and of itself, that with all the cool things that have been happening in agents over the past 18 months, we should probably talk about how we would think about agents today and what people can do with them.
So as long as you don't forget the part about applicability and how we use agents, sounds great, let's do it.
All right, why don't you kick us off?
So, okay, we always start these things by making sure we're all on the same page about the definitions of the concepts we're working with. So let's set a definition for an agent. The simplest way to think about an agent is that an agent can observe the world around it, use tools to interact with the world in order to accomplish a goal, and agents can take action on your behalf or even act autonomously to accomplish a goal or perhaps find a goal.
Interestingly, I think even 18 months ago, that definition has remained pretty durable and consistent.
Yeah, it actually has, but my brain works best with examples, not theory. So do you have some favorite agent examples?
Oh, I have a lot of them. Let's talk about one of my personal favorites, a customer service agent that can help users out with a variety of requests, like answering questions about order status, helping people with returns, or maybe even scheduling callbacks or service calls for more complicated issues.
You really like that one. Personally, I really like that productivity agent that I built that looks at my weekend to-do list and estimates how long each task will take, breaks up the big tasks, and then helps me schedule anything with minimal context switching, including putting things on my calendar.
That's pretty cool. Or how about an agent that knows what's in your refrigerator and pantry and automatically reorders things for you when you're running low on something and does it in a proactive manner?
That would be awesome. Or how about we use the example that seems to be everyone's agent example these days, a travel agent that can pick a destination, find hotels and flights, and plan an itinerary for your trip that fits your vibe.
Ooh, so many vibes that we could do for travel. All right, that's one that everyone uses, but I have one that even more people use. Let's talk about an agent that helps you write code and deliver software for an idea you have, or for creating a feature, or even adding AI to an existing application or an AI agent.
So a lot of people really do use that coding example. So now we have a couple examples and we got a good idea what an agent is. Let's talk about what's changed in the last year. And one of those things is that the way we've architect agents and publish and share them has actually evolved quite a lot. So let's level set first on the components of an agent. An agent obviously needs to have some sort of model it uses for inference or intelligence, tools to interact with the world around it, and context or memory so that it gets smart about a task over an iteration or over multiple iterations.
All right, let's break down each of these, starting with the brains of the agent. Nowadays, many models are what we call thinking models, which just means that the model has some level of ability to self-reflect built in. These models are good for agents where tasks may be complex and the model needs to consider a set of ideas or responses before it makes a final response to the user or another agent.
Okay. Next, let's talk about the tools. This has actually changed a lot recently. Many agents use a protocol called Model Context Protocol, or MCP, to access and use tools. And now, since I'm mostly an application developer, let's actually talk about what MCP does. Jason, do you remember APIs?
Absolutely not.
MCP is kind of like an API, except it provides additional instructions about how an API is actually used and what the meaning of the inputs and outputs are. This gives the agent knowledge about when and where to use a specific MCP tool or an API in specific situations.
And agents wouldn't be complete without memory. You can think of memory in the most simple form as the context window for an agent. There are other forms of memory like short-term memory and long-term memory that you can also put with an agent architecture. Agents generate context-based memory as they perform interactions with their users or with other agents in a system. As the context builds, the agent will generally have a better understanding of the task, what tools are available, and other items that are relevant to the goal. It may also use short-term or long-term memory to augment its context in order to achieve one of its objectives. However, context, just like when you're working on a task, requires active management. You'll want to think about updating the window as a task evolves, which could mean compressing context, summarizing context, throwing context out if it's not relevant, or using other memory pieces to bring more context into the agent for it.
Okay, so we've defined an agent, we've talked about the parts, let's talk about agent patterns now. Obviously, this will not be an exhaustive list, but hopefully this will help our viewers see a few different patterns they could apply to their own agents. And when we say agent patterns, what we mean is ways that you can create an agent or how you could create a team of agents that work together for a goal.
All right, I'm going to take the most simple pattern. And the most basic agent pattern I could think of is an agent with no loops or other agents. In this example, the agent has a set of instructions, maybe some tools, it's connected to a model, and that's it. And let's talk about an example of when we want to use this. This pattern is very simple, but we could do this for getting started with an agent, or even an agent where the objective or directive is very clear. And it's a great starting point for us to learn about agentic behavior and then apply this to more complex use cases down the road.
Okay, so let's talk about more complex use cases. Another pattern you could use is the sub-agent pattern. In the sub-agent pattern, the main agent handles most tasks, but it'll offload specific or specialized tasks to another agent that it has access to. In the sub-agent pattern, we typically hand off a task for completion, but we are selective about the context that is applied. We might do this for something like processing an invoice, where the agent that actually gets the invoice information from a document is a highly specialized agent, and the overall agent is a general worker who can move the work from step to step to get it through the entire processing pipeline.
And that's super cool because it leads us into another pattern, which is the orchestrator pattern. In this example, the starting agent acts like a router. The router agent then sends requests along to the next agent that it has determined can best answer a request that a user or another agent has. And while the router may seem simple, identifying the intent that a user or another agent has can actually be very difficult to do right. It has to be fast at doing this and to get the user to the right agent for the next level of intent to answer a question, for example. You could think of this like an overall agent that handles a storefront for questions related to ordering, orders, or support, and has to hand off that intent to the next available agent in it.
I think those are good starting points. There are other agent patterns out there, so don't feel like these are the only ones that you can use, but these patterns do represent and cover a common number of use cases. And we have links below where you can try out these patterns and see how they might work for your use case. We hope that you've enjoyed our update to agents today, and with that, this is Aja and Jason. Happy prompting!